Hey team, welcome to the numbers game. I'm Coach T, and in this tutorial we'll be executing a proof using Euclid's lemma. Let's get started. Euclid's lemma states, let P be a prime and let A and B be integers. If P divides A times B, then P divides A or P divides B. This lemma is often used in proofs of irrationality, and our example says, show that the square root of 20 is irrational. So let's go ahead and start proving this. So the first thing that we want to do is assume that the square root of 20 is rational. If the square root of 20 is rational, then there exists positive integers a and b such that the square root of 20 equals a over b, and the greatest common denominator of a and b is 1. And this is by the definition of a rational number. So next we see that if we multiply both sides times b and square both sides, we get 20 times b squared equals a squared. Now, you may have come across other examples where you're asked to prove that the square root of a number is irrational, and the next step typically would be to say because 20b squared equals a squared, then 20 divides a squared, then 20 divides a. However, this line of reasoning doesn't hold true. For example, 20 does divide 10 squared, so 20 does divide 100, but 20 does not divide 10. So this line of reasoning is not going to hold. Most notably because 20 is not a prime number, and for this to hold, we need a prime number. So what do? Well, and note this stuff in purple is not a part of our formal proof. Let's take note of the fact that the square root of 20 simplifies to 2 square root of 5. So in the same way that we said the square root of 20 equals a over b, let's say that 2 square root of 5 equals a over b. We'll follow the same process by multiplying both sides times b and then squaring both sides, which gives us b squared times 2 squared times 5 equals a squared. Hence, we now can clearly see that 5 divides a squared. By Euclid's lemma, because 5 is a prime number, we know that 5 divides a. And then we see that a equals 5c, where c is some integer. Then we see that when we plug in a equals 5c into 20 times b squared equals a squared, we get 20 b squared equals 5c squared, which equals 20 times b squared equals 5 squared times c squared. Now we can rewrite this expression as 5 times 2 squared times b squared equals 5 times 5 times c squared. Hence, 5 divides 2 squared times b squared. And by Euclid's lemma, 5 divides b. If 5 divides b, then the greatest common denominator of a and b is 5. However, this contradicts the fact that we found earlier, which said that the greatest common denominator of A and B equals 1. Hence proved. And there you have it. By contradiction, we were able to prove that the square root of 20 is indeed an irrational number. If this video was helpful for you, give it a thumbs up, like the video, and subscribe to the channel for more math tutorials. I'm Coach T, and thanks for watching The Numbers Game.